Hi guys, welcome to your Unit 10 Lesson 4 notes on solving multi-step inequalities. Before we jump in, let's remind ourselves how to put on our socks and shoes. So when I put my socks and shoes on, I first get out my socks and my shoes, and then I put on my socks, and then I put on my shoes. So that's my strategy. Cool, awesome. Now, how do I take them off? Well, one would think they're going to be the exact same steps, right? But we just need to undo them. So instead of getting out socks and shoes, we put away our socks and shoes. And instead of putting on our socks and shoes, we take them off, right? Right? One would expect. But let's look at this order a second. Can I put my socks and shoes away before I even take them off? No, and I can't even take off my socks before I take off my shoes, so I need to rearrange these a little bit. The very last thing I'm going to do is put away my socks and shoes. And before I can even take off my socks, I need to take off my shoes. So notice what we're doing here. What was our first step, getting out our socks and shoes, becomes our last step. Putting them away comes last. Okay? Socks is still going to be our middle step. But what was our last stop, putting on our shoes, now becomes our first step, taking off our shoes. So while we followed one order, we're actually going to reverse the order the other way. Okay? So that's our key idea of the day. To undo a process, it's not enough to just undo it. You must also reverse the order of the steps. Okay. Remember that when we're solving equations, we need to undo what's happening to the variable. So the first thing that's happening to the variable is we want to undo this minus 2, this multiply by negative 2. So we're going to divide by negative 2 on both sides, giving us negative 4 equals x minus 5. And now we can undo that negative 5 by adding 5 to both sides. So we get that 1 is equal to x. Cool. Awesome. So that's a quick review. Today we're going to solve not equations, but we're going to solve inequalities with more than one operation. Yeah, so here we go. So all this talk about undoing and reversing. We're going to put that into context with bright orange. That's go pink so you remember it. Okay. Y'all remember PEMDAS, right? When we simplify an expression, we start with parentheses and exponents. And then we do our multiplication and our division. And after that, the last thing we do is we add and subtract. But when we're solving an inequality, we want to get the variable all by itself. We want to get that variable alone. So to solve a multi-step inequality, which is our whole goal here today, we're going to undo, yes, we're going to undo what's happening to that variable, but we're going to reverse the order of PEMDAS. So the first thing we're going to do is we are going to add and subtract. And then, I didn't want to do that. The first thing we're going to do is we're going to add and subtract. The second thing we're going to do is we're going to get the I on our, the dot on our I, and then we'll multiply and divide. After that, we'll take care of exponents, and after that, we'll work inside the parentheses. So here we go. So instead of PEMDAS, we have this new fancy word that's going to help us out. You ready for it? Instead of PEMDAS, like you've heard of PEMDAS, now get ready for Osmodep. I'm just kidding. It's not helpful. Okay, first, we want to undo addition and subtraction. So to get this variable all by himself, we're going to first undo that 4. That'll give us 2x is less than or equal to 8. Now, to get the variable all by itself, we want to undo the 2 times. To undo the 2 times, let's divide by 2, which gives us x is less than or equal to 4. Cool, right? Let's do another one. Now, we want to work with our asymptote. What's the first thing we want to undo here? First thing we want to undo is addition or subtraction. So we're going to use addition to undo that subtraction, giving us that 8x is greater than 16. Next, we want to use multiplication and division. Dividing by 8 will undo that multiply by 8. We have x is greater than 2. Cool, huh? Cool. Here it gets a little complicated because we can't add yet. We've got parentheses, and parentheses come last. So there really is there's not an addition or subtraction to do, but there's a multiplication and divide. So we're going to divide by -2, and that gives us that -4 and x minus 5, but careful, we divided by a negative number, which means we need to flip that guy around. Okay, we have -4 is less than or equal to x minus 5, so finally we can undo our minus 5 to get our x alone. This gives us 1 is less than or equal to x. That sounds really familiar. Check that out. All right, cool. For our last guy, we're going to work on our asymptote. But first, we want to get all the variables to the same side. So we've got a -4x here and a 6x over there. I like to work with positive numbers, so I'm going to add 4x to both sides. Once I do that, I'm left with 3 is less than 23 plus 10x. Now I go through my list. As asymptote, I can undo some addition and subtraction, giving me that -20 is less than 10x. Now to get this x all by himself, I want to divide by 10. So I get that -2 is less than x. And now we are all set. So remember, when solving inequalities, you need to undo your order of operations. You need to do PEMDAS, backwards. Because solving an inequality is just like solving an equation. Just there's inequality instead of equals. That's cool and all, but when are we going to use this in real life? Well, let's ask Eric and Mariah. So this one time, Eric went to Puerto Rico, or we're going to pretend he did, and the temperature there was always warmer than 30 degrees Celsius. So we're going to use this formula right here to write and solve an inequality for the temperature in degrees Fahrenheit. Well, we knew whatever the temperature was, well, we've got this temperature, 5/9 F minus 32 equals C. And what do we know about our temperature? Well, Celsius was always greater than 30. So now we can write ourselves an inequality. We're going to replace this Celsius with a greater than 30. Now let's figure it out. The first thing we want to do is we want to get rid of this 5/9. So I could multiply by 9 and then divide by 5, or I can do those in the same step. Nope, wrong step. I can multiply by its reciprocal. So times 9 divided by 5. Now these guys cancel out. That's great. We're left with F minus 32 is greater than, how are we going to do that? Well, 30 is like 30 over 1, and 30 and 5 are going to reduce out because 30 divided by 5 is 6. So 6 times 9 gives us 54. And then finally, we have one more step to get F by himself. We need to add 32 to both sides. So on Eric's trip to, where did he go? Puerto Rico. It was always warmer than 86 degrees. Awesome. Hope you had a great time, Mr. Eric. And finally, back at home, Miss Mariah is calculating the lowest score she needs for her good grade. So Mariah's scores on the first 3 of 4 100-point tests were 85, 92, and 90. Okay. What score must she receive on the 4th test to have a mean score of at least 92? Well, let's for 1 second just be like, okay, what's the score? The score is going to be S. So let S be the score on the 4th test. We also need to know what the mean is. Remember, mean means average. So to average her scores, we're going to add them all up and then divide by how many we have. So her scores were 85, 92, and 90. And now the question is, what is her last score going to be? So we're just going to make that S. S for score, I guess. Now, she wants at least 92. So a 93 is fine. 100 would be great. Either way, these scores need to be greater than or equal to 92. Okay, we've got our inequality. Now let's simplify it. I'm actually gonna, real quick before we do this, let's add up 85 and 92 and 90. Those add up to 267. So our real inequality is 267 plus S all over 4 is greater than 92. Okay, now let's solve it. So the first step is we want to get rid of this divide by 4. To undo divide by 4, we're going to multiply by 4. These will cancel out all nice. That's really cool. We hiccup once, and then we say 267 plus S is greater than or equal to 368. We have one more step to solve this inequality. We need to subtract 267 from both sides. This tells us that S is greater than or equal to 101. Oof, Miss Mariah, you better hope there's extra credit on that test, because you need a 101 out of 100 to get a 92 overall. Regardless of your test scores, you guys still matter to me. Remember to undo the order of operations, to reverse the order of operations, and have a fantastic time on your homework.